Welcome, everyone. Thank you so much for joining our webinar today on APIs. We're so excited you're here. This is our first webinar in our API series. I'm your host, Nicole Feltz. I work in USGS's water mission area as a science communicator. In today's webinar, we'll be talking about APIs, Application Programming Interfaces. We'll give you a brief background of what they are. Then we'll dive into a demo of one of our new APIs, SensorThings. We encourage you to submit questions throughout today's call, as we will answer them in the second half. If we are unable to get to your question during this webinar, please send us an email at wdfn@usgs.gov with the subject API Webinar. Today's webinar is being recorded, and the recording will be available on the WMA website and on the USGS YouTube channel. We'll be posting announcements in the chat throughout today's call, so look out for those. I have one formal announcement to make before we dive into the main content of today's webinar. Do you use Endless Web? If you do, please fill out our annual satisfaction survey. It helps us help you, and it'll only take 5 minutes of your time. The link for the survey will be posted momentarily in the chat. Thank you so much for your participation. All right, let's kick off today's API webinar with a live poll. Where did you hear about this SensorThings webinar? It is super easy to join this live poll. There are 3 ways that you can join. Go to slido.com and enter the code API. Use the link we'll be posting in the chat for convenience momentarily, or scan the QR code on the screen. We're excited to see how you found out about this webinar. We've posted on Twitter quite a bit about this, a little bit on our Instagram. We sent out an internal email about this, and we also sent an email to our subscribers to the new Water Data for the Nation newsletter. Maybe you heard about this from a friend or interested to see how you found out. We're going to hang out on this live poll for just a minute or two to get some responses in. So we have about 274 people that are actively in the webinar right now. Let's see if we can get to at least 100 responses on the Slido before we move on. Oh, I'm so curious to hear where everyone found it if it was somewhere else. You should email us if you have time to let us know. Curious. Oh, we're quickly reaching 100. Can we get to 150 before we move on? A lot of people got it from the internal email. Neat. All right, let's cap it off at like 125 responses and then we'll move on. You can still participate in the live poll as we move on. So feel free to keep contributing your responses as the poll is still open. The poll will close when we move on to the next poll, which is later in the presentation. It's really cool to see those live responses right away. Okay. All right. So now I will turn it over to Jim Kraft, Product Manager for Water Data Processing and Web Services. He'll give you some key background information on USGS Water Data and our APIs. Then he'll give you a live demo of SensorThings. Take it away, Jim. Hey, Jim, you're muted.
I am. Now I'm not. Started out. Let's explain where. Thanks, Nicole. Hi, everyone. I'm Jim Kraft, and I'm very excited to be presenting this today. Some of this work was kicked off over almost a year ago, and now I'm pleased to be able to be sharing it with a broader audience. So first, a little background. Why do we care about water data APIs? Each dot on the map here is an active stream gauge. And if you look at the graph on the bottom of the page, you can see that the number of stream gauges has increased over time, resulting in over 8,000 gauges that are currently active in the USGS network. Active gauges collect a wide variety of data, and we can do so many cool and powerful things with this data. The way that we've historically shared and communicated that data has been ineffective. Preventing the data from being used to its full capacity. Even though we know that many users take advantage of our data, pull data from our web services, there's still way more that we could do, and many users who have been put off by the way it's currently structured. So to better communicate the water data to the nation in a discoverable, accessible, and usable way, we've improved existing APIs and we're embracing new ones. That's just what we're talking about today. Utilizing APIs allows us and our users to answer all kinds of questions like, how high will the water get? Is there enough water for people and farms? Are conditions good for fishing? How many turbines can I run? Which roads are flooded? And other critical questions that are based on water data. And we can answer these questions using APIs. But what are APIs? They're the magic behind the screen that programmers use, allowing us to communicate between systems. Everything that you do or see on computers is driven by APIs at a variety of different levels. But if all APIs are important, what makes USGS APIs special? At USGS, we collect a lot of super cool and also just critically important data that deserves to be properly showcased. And our APIs allow for automated connections between our USGS source systems and your systems. APIs can then build on that connection and interact with data provided by the USGS. For example, the EPA How's My Waterway application pulls the latest data from SensorThings, the tool we're talking about today, and puts it in context with information and data pulled from a number of other APIs. So who are USGS APIs for? The users that benefit from our APIs fall into two broad user groups. Operationalized pull users, who pull data from USGS systems at regular intervals, often in automated ways, and use it to make decisions, often in the context of other data that are put together in secondary systems. And explore and download users who interact with our data in a number of ways and interact with it and create a number of different types of analyses. And these are especially the users that use tools like R, data retrieval, and Python to access our data. You can check out our recent blog post on Water Data for the Nation, on Water Data for the Nation users. The link to the blog is at the top of this slide and will be shared in the chat. Now we'll move on to another Slido.
Thanks, Jim. I'll go ahead and lead us in this Slido. So this particular live poll, we are asking if you have used any USGS APIs before. So this Slido is the way you can join is the same as the other one. You can go to slido.com and use the code API. You can scan the QR code on your screen, or you can use the link that will be posted momentarily in the chat. I'm really excited to see maybe some additional feedback from the people who are saying no, but I'm excited to try. I love how there are a substantial number of people in this webinar who've never used them before. I really want to hear from you. Please join the subsequent webinars in our API series so that we can hear from you again if you have tried them out before our next webinar. All right, we're definitely seeing a trend. We have a consistent trend here that there are a lot of people in this webinar who are familiar with our APIs. They use the legacy ones. We've got quite a number of people who have never used any of the USGS APIs before. And some who have used our new ones. This is great. All right, so again, this Slido will stay open and you can continue responding to it until we go to our next Slido, which will be at the end of Jim's presentation. So Jim, I'll turn it back to you.
All right. Thank you, Nicole. And let me just, there we go. So what is SensorThings? When we started to look at what to do with a new sensor data structure, because we knew we needed to build a new system, we looked at existing standards. And we determined that the most appropriate place to start was SensorThings. Because it's a specific API for accessing data collected by sensors, and it was developed as a lighter weight internet-first protocol to support the Internet of Things. It's an open geospatial consortium standard, standards body the USGS is a member of, so we can contribute to future versions. And it's about supporting the Internet of Things. Most of us are familiar with doorbell cameras, smart fridges, and other types of objects that send data back to a central location. It's HTTP focused, but sending things over the internet, and it allows for both event-driven and REST-based interfaces. And it speaks JSON, the common data structure of data on the web. It's been gaining broader adoption for environmental data since it was adopted by the EU Inspire project for sharing environmental data across the European Union. But it can work with nearly anything that sends data around via the internet. So how do we use SensorThings? The USGS uses many different ways to collect sensor data, but our goal is to have all that data available via SensorThings. And currently we use it for data access to the real-time time series data. This is one of the largest, if not the largest, SensorThings implementation in the world. But we also know that we don't have everything right yet. As a result, we are presenting this to you early for feedback. And in addition, we are now a member of the SensorThings working group in the Open Geospatial Consortium to participate in the evolution of the standard as it moves forward. We want to hear from you about how this standard will work and what will make it more useful in the future. Okay, that was a lot of technical stuff. So TLDR, the SensorThings is very relevant for our work, and we weren't using it at all. Now we are, and so we're looking to get feedback from you on whether it's effective. We've talked about what we use SensorThings for. Now let's talk more about the SensorThings data model and how it's associated with the USGS. At the USGS, our things, in this case, we'll start with the things part, are fixed locations, are monitoring locations. Each thing is a single location. Here we have location 0104800, the Sandy River near Mercer, Maine. We maintained the familiar identifiers for monitoring locations in SensorThings, so it's easy for you to find your favorite locations if you know the site identifier. You can see that identifier there at the bottom of the slide. The SensorThings data model supports the concept of moving things, and it's a future enhancement we look forward to, but we haven't implemented it yet. All of our things do not move. So let's take a look at the next part of the SensorThings data model. Data streams. Each thing is associated with one or more data stream, and a data stream is a time series. There's about 35,000 data streams that are publicly available, one for each of the publicly available time series. As an identifier for that time series, we use an identifier from an upstream system as a key, which we hope will allow for a more stable reference to these data streams as we move forward. Tied to each data stream is an observed property. Observed properties are mapped to USGS parameter codes. So for gauge height, for example, it's good old 00060. One thing to note is that in addition to observed property, the other key piece in data stream is the actual observations, which are also one set of observations per data stream. One thing to note about the observations, which are fundamentally a time and a result, along with some additional metadata, is that the time is always going to be UTC. Manipulating time zones, daylight savings time, and other complications of time are on the user to determine what's most relevant to them for time zone conversion. In addition, units are tied to data streams, and we store metadata in the properties for the data stream, including things like operational thresholds, which previously have been essentially impossible to access for an outside user. Well, the legacy data structure may have had many of these same elements. The way it was structured was confusing. One word I saw used was Baroque. And we're hoping that this new metadata model and more data model is more accessible and usable. And we want to hear from you how well it actually works for you. So how do you query SensorThings? And how do you make use of it? We'll go over more of the details in the demo, but essentially it uses another standard called OData, which is a powerful query language, but might not be familiar to some users as, say, a basic parameter-based REST endpoint. If you're familiar with Microsoft.NET and their API and Microsoft API endpoints, you're probably familiar with OData, and you may be able to jump right in. Otherwise, there's a bit of a learning curve, and Google will probably be your friend. One thing we'll also be providing as many examples and other tools as available to be able to give you context for this new data structure and way to query. One thing to note is that responses are not OData compliant. So you can't just plug in an OData client to SensorThings and get it to work. But that's something that's being explored by the standards working group right now for future versions of SensorThings. As we know, there are other approaches to querying data, whether that's parameter-based endpoints or other approaches such as GraphQL. And we want to hear from you so that we can learn how to best build alternative querying approaches to make this endpoint work best for as many different programmers as possible, so that we can make use of this everyone can make use of this new endpoint most effectively. So SensorThings can be used in several ways, but it currently has limitations. Fundamentally, we're focused on recent data. If you want older data, you'll have to use the legacy endpoints, but we're modernizing more in the future, so stay tuned. We are discussing more ways to modernize these endpoints, and you can expect to hear more from us in the coming months and years. You can learn more about all of our major web APIs in a recent blog post that we will drop in the chat. So what should use USGS SensorThings? Things like dashboards, apps, decision support systems, smart devices, and more. Essentially, if you need to make a decision based on recent water data, if you're making predictions or models, if you want to put the gauge height for your favorite monitoring location up on your refrigerator, SensorThings is a great option. There's a lot more things we're going to be doing with SensorThings in the future. One around reliability is we'll be moving it to a more stable URL. Instead of from labs, will be something like api.waterdata.gov, which will come with more monitoring support and more consistent data updates. Hopefully within essentially seconds of data coming in to an upstream system, we want to have it out on SensorThings. We'll also be adding additional structured metadata. We also know that we're not using everything available in SensorThings. And so we're working to offer additional components, and we're looking forward to doing things such as event-driven data access with MQTT, and adding additional sensor components such as sensors, multi-data streams, and features of interest. We want you to get involved with our API usability testing. So email wdfn@usgs.gov with the subject API usability testing. We want to know from you how easy it feels to get started using USGS APIs, if our docs make sense, and if our client libraries make it easier to use our systems. Consider registering for the other 2 webinars we currently have scheduled in this series about APIs. Links are in the chat. Now let's participate in our last live poll before we give a demo of just how SensorThings can be used. Nicole, take it away.
Thanks, Jim. All right, so for those of you who are just joining or didn't have the opportunity to join our other live polls, it's really easy to join. Just go to slido.com and enter the code API. This particular poll is going to be a little bit different. It's a word cloud, so we're asking you, what do you use USGS APIs for? Because this is a word cloud, the most popular answers will appear the largest on the screen. This might be a really interesting opportunity to see whether the use cases overlap or whether they're all just totally different. So let's see what you all have to say. And the link will also be in the chat too. There we go. And the good thing is, if you see a response that's really similar to yours, you can essentially upvote it so that that word becomes even bigger and it forms into like a word cloud with different sized words instead of a word cloud with like a bunch of really different terms. I don't use them yet. That's a good response. Water quality and modeling for use in dashboards makes sense. Daily statistics, nothing yet. Flood warning, that's really important. To extract time series data, machine learning, stream flow conditions. This is so cool. I love watching how it like changes instantaneously, and we love looking at this data after webinars. So thank you to everyone who is participating. Let's try and see if we can get to 100 responses, and then we're going to transition into the live demo for the day. After the live demo, we'll have an opportunity to answer questions live. If we're not able to answer your questions live today, please send us an email at wdfn@usgs.gov. This is a really nice looking word cloud now. We have a really wide variety of responses. It seems like people who are participating in the earlier polls where we were asking if you use USGS APIs, they're also responding. I love that. All right. So as with all the other live polls, you can continue responding to this one for however long until we close it at the end of this event. So please keep responding to it. And now, Jim, if you're ready, we will go ahead and transition to the live demo.
All right. So I am just going to actually keep Edge open here. And we are way earlier than we're supposed to be, so we'll go up to the top. So this is, we'll be doing this demo in a Jupyter notebook because my space is in Python, but it will be we'll be working on getting this notebook, the content of this notebook, also out on the web, so you can access it and use it, and be extending it as well. So let's get started. I'm going to be looking away from my camera, so I'm just going to turn that off. So, okay. Oops. So let's start with listing all the station locations. So in this case, we can look at, we're going to be in Arizona mostly today. And we can start with the oldest USGS stream gauge, the Colorado River at Lee's Ferry, Arizona, which we can access at this thing URL. And what do we get back? We get back something that looks like this. So we get some basic information in the properties of the thing. We get back a bunch of station of metadata about the location, including things like the URL, the name, what type of a location it is. Also, additional information to the other parts of the SensorThings data model. So let's make a request to the SensorThings API for all the stream locations in Arizona. Let's take a look at what that query looks like. Oops. So what we're pulling from is we're going to be hitting the things endpoint, and we're going to be using an OData concept called a filter. So we're filtering on that monitoring location, that properties of monitoring location type is stream, and that the FIPS code, the identifier for the state, is US4 or Arizona. And we get back a couple of queries. The other thing to note here is that this allows us to, you can also skip. So SensorThings allows for paging. And so this makes 100 and then jumps to that next 100. And so we've got things set up in a client such that it can make those types of things. So if you're getting thousands and thousands of responses, you can just roll through and build the response that you need. We'll also be extending the max number of things you can get back, probably to around 10,000. So then you can pull all that data into a in this case, we're going to pull them into a pandas data frame by using a tool called JSON normalize. And so that brings all that information into a nice structured way that can allow for additional querying. And you can actually just pull that directly into a map and get a little bit of additional information. Now let's go a little bit farther. Maybe we want to get discharge information. So that's adding quite a lot of additional information. And we can again do this through SensorThings. So again, we're using that select where we're pulling different pieces of information. We're using the select to get maybe not as much information. We just want the properties and the ID. We don't want a lot of that other stuff that we're not going to use. Then we want to filter by data streams that have observed property identifier of 0060. And the properties, the monitoring location type of stream. And we also want the Colorado River, the HUC2 of 15. And this is where you can also see, you can do some things like substring queries within OData. So we've got actually the HUC12s as available through hydrologic unit, but you can use starts with to get a little bit far, to dig into even within that string. Then we want to get the location information. And then also, and this is where we're looking at, see, this expand operator allows you to pull additional components of the SensorThings data model into the into here. So we've got locations, and then from the locations we're grabbing the name, description. We've got data. We're pulling data streams and information from there. We're also we only want, again, that 0060, and we're also getting observed property information, as well as the most recent one observation. The other thing, and we're ordering it by phenomenon time. So we can here, this allows us to get the most recent one observation from this system. And the other really powerful thing is that SensorThings data standard has been extended by the tool that we're using called Frost Server, which is a implementation of SensorThings. And they've listened to their users already, and their users have said, hey, sometimes I just want GeoJSON because I want to just pop it on a web map real fast. And so you can not only get the core SensorThings JSON, but you can also get GeoJSON. And here we're saying, hey, we just want the top 1,000. This is a limitation of GeoJSON, is that it doesn't have a paging structure built into it. And so you may want to get a bigger set. And this is, again, why we're going to be extending what that top number is that's available. And with that, you can make a quick map. Here we go. We've got all the locations. And you can actually just explore a little bit. And this is using a tool called GeoPandas to just make this real fast. But we can do more. Make a little bit more sophisticated map. And take that observation information that we had and scale the size of the marker by the discharge. So we've got the Colorado River, obviously, and then we also have a variety of smaller tributaries feeding into the Colorado. You can see within here we've got gauges on tributaries within the Colorado that are also feeding in. And of course, you can grab, in this case, we're just grabbing the discharge and the name. In addition, you can plot time series information. And this is, we're hitting a slightly different structure to the endpoint here, because what we're going to try to do is get all of the data streams for a single location. In this case, we're looking at, again, we're going back to 0938000, the classic, one more zero, the classic USGS location. We want all the data streams, and we want all the observations that have been selected since the 8th of January. And we're again ordering by phenomenon time. So what do we see? Here we go. We can pull all the different data streams that we have here. You can see that we've got a bug in our data loading right now, and there's a couple places that there's missing data. We are hoping to have that sorted out in the next few days. So we should have very consistent data that's really now is the same type of data that you'll see coming out of the legacy systems. So now let's do something even more complex and structured on another endpoint. And this is to query on observed properties. So in this case, what we want to do is we're looking for all of the observed properties that are 00010. Those who are familiar with that identity parameter code, that's temperature. And so we want all the data streams that are associated with temperature. And again, we want all the observations that are, and just the time and the result, again, from the 8th of January. So we're paging through, we're pulling over 2,000 different data streams that are available. And here we can just take a little bit, see what's actually coming back. And you can see that observations and the phenomenon time. Just the key thing, there's the time and the result. And you get a long set of key value of arrays, list of arrays here. And now you can just plop all of those things together. And here we have all 2,000 water temperature time series across the country. Obviously, we've got a few that are much hotter than the others. The vast majority are here below 40 degrees centigrade. I'm really curious what's all going on here, whether we're in hot springs or what all is happening to get water temperatures above 80 degrees or even above 40 degrees. And there's a lot more that we can do. But this is this gives you a view into the ways that you can structure this data and now and access this data. And now we're going to move on to the Q&A.
Great, thank you so much for that demo, Jim. That was awesome. Jim, are you able to just put up the Q&A slide?
We are getting there.
Okay, cool. All right, so we'll take a minute to start our Q&A here. Got just a little bit less than half of our planned time for the webinar today for Q&A. So we're dedicating a lot of space to answer questions from our audience. We have a few questions that have come in the first half, so we're going to start with those. Any questions that arise, you're welcome to put them in the Q&A feature and we'll get to them as we're able. Any questions that we're not able to get to during this webinar, please send us an email at wdfn@usgs.gov. Okay, so the first question asks, can you explain more about how SensorThings is only for the last 120 days? Jim?
Yeah, so we chose 120 days because that's been where our highly available data is available on our legacy systems. If you go to waterdata.usgs water services or waterdata/instantaneous values, our high availability servers, where we've got 12 servers across the country, that's only for data that's available through 120 days. And that's sort of a number that we've arrived on as sort of where our high availability needs to be. And that's where we started for SensorThings as well. A huge portion of our users are asking for data that's just 120 days. We also know that there's another huge chunk of our users that need all the data. And we are going to be working to support them as well, though potentially not directly through this SensorThings endpoint.
Great, thanks, Jim. The next question is there a Python library available to work with the API? Jim?
So right now, there's not. That's especially not that's super structured, it gives you a lot of availability. And though this is something that we are exploring supporting. In the Internet of Water team group, nonprofit that's is coordinating water data work across the country is also going to be building a SensorThings client for both putting data into SensorThings, but also getting data out. And we'll be working with them as well. So that's something that's coming, our client libraries for both R and Python.
Okay. The next question is, do you have a tutorial available for accessing USGS data using R commands and packages? Jim?
Yes, we have extensive documentation on how to use the R data retrieval package for everything except SensorThings, which we will be adding functionality to in the future. And so we can put a link to the chat for that as well.
Great, thanks. The next question is, we use Excel and its filter XML function to generate the report we need. Will these new APIs impact our work? Jim?
So I saw a very exciting demo, actually, for if you're in Excel space, OData, an OData-based API will be incredibly powerful for you because Microsoft loves OData. And so we are actually there. I saw a demo of the next version of the API that supports the OData directly, and they were able to point Excel at this endpoint and just do all sorts of really cool things. And so right now you'll have to do some manipulation, but moving forward, Excel-based workflows and SensorThings could be a very powerful option. Similarly, with tools like Microsoft Power BI or other tools like that, we'll be able to directly plug into SensorThings.
Great.
So yes, it will affect your work, but it should be in a positive way.
Nice. Cool. All right, the next question is, will this replace the service found at USGS Water Services site? Jim?
Currently, this is in addition to the services that are at the water services at USGS.gov. Eventually, we will be replacing most of those services with new ones as we move forward.
All right.
But,
next question. If I have a URL I use with a legacy system, will you provide ways to translate it to an equivalent for the new system? Jim?
That's a great question. Sometimes we may be able to build say a translation layer within, say, especially within client libraries like data retrieval. But we'll also be providing extensive documentation to show, to be able to translate current use cases and the current data structures to these new data structures and use cases. And I really encourage you to reach out to us with your use case and so that we know about it and can make sure to be able to support it as we move forward.
Okay, great. This question says, beyond what you showed in the live demo today, how can I learn more about how to use OData?
So we'll be linking to a number of features. For example, the OData, I think it's odata.org. And also there's a lot of SensorThings demos that have been developed to support this the Inspire project over in the EU, and those are all conveniently in English. And so there will be a number of different resources available, and we'll be pointing that to we've got a new blog post that just came out that includes discussion of SensorThings and points to some of these, and we'll be adding a lot more as we move forward. And that blog post link will be coming out in the chat.
Great. Yeah, I'll put that in the chat again in just a sec. Okay, the next question is OData querying used in any other OGC standards, including OGC API? Ooh, that sounds like our
that is
webinar.
A great question. Essentially, this is where, the OGC API initiative, SensorThings essentially predates the OGC API initiative, which fundamentally is rebuilding all of the OGC APIs to be more developer friendly. And there is a goal over the course of the next year or so to extend the SensorThings structure to work within the paradigm of the OGC API space. And I recommend if you're trying to, I really recommend coming to the next seminar where we talk about OGC API to get more details about OGC API, or just Google that to figure out what's going on there. But yeah, that's a great question that is very, very relevant.
Yeah, a great one. Okay. Next question. In SensorThings, is there a way to write a simpler query just using the USGS station ID? Jim?
So that's a great question. So a simple query, such as you can, for example, if you want a single thing, you can actually query by the identifier directly within things. So that is always one option, and you can always query by identifier, and that's one of the reasons why we tried to bring existing identifiers over, is so that it could be more approachable. So yeah, and then you can from here you can actually dig into the other parts, and that's a great way to explore this API, is to put in a thing and then go from there.
All right, the next question Emily responded to in the chat, which was, why would you want to move things? Don't you want a single site to represent a very specific location? Jim, if you have your own take that you want to add to that, you're welcome to.
I am struggling currently with getting to the right chat window. So essentially, we know that we've got a lot of, I'll just making sure, we know that while we have an extensive network of fixed locations, we also know that right now, USGS scientists are attaching sensors to boats and driving up and moving around. We have drones, we have autonomous underwater vehicles. All of these are sensors, and we need to be able to tie those sensors and make that data available. And that's just, our current data structures, our legacy systems have no way of really effectively doing that, but SensorThings does. And so there will always be easy to tell the difference between those two things, but we do need to be able to support a moving sensor as we move forward.
Great. Yeah, that was an excellent addition to what Emily said in the chat, and I found what she said. Could have read that to you a second ago. Moving on to our next question. This person says, I'm using waterdata.usgs.gov/NWIS/DB to get data from NWIS Web. Will that keep working? Should I be doing that? Jim?
That's a great question. So right now it will keep working, but if you're using, I highly recommend, if you're using water data, a URL that starts with water data, like that one, /NWIS/DB, to move to waterservices.usgs.gov/NWIS/DB, where you can get data that's shaped exactly the same, but is not piped through another layer of legacy software. And we'll be expecting to support water services components and legacy systems, because we know that there are thousands of different systems that depend on our legacy services, on water services. We'll be supporting those for far longer than we'll be supporting the legacy pages on, say, waterdata.gov/NWIS/DB. So yeah, and you should be a pretty easy change from one to the other, but that would be the direction I would push for the moment until we get our new services out.
Okay. All right, the next question is, what is the status of documentation for SensorThings API?
That is a great question also. So there's a couple different pieces. So we have an initial, as we talked about, there's the blog post about all of our different API catalogs. We will be putting out additional, as soon as they get through approval, additional things like the content of the demo and other pieces of specific SensorThings support. And we will be building additional pieces. So right now it's relatively skeletal. In the next few days, it'll be more. In the coming weeks and months, it'll be even more with different pieces.
Great. All right. And we did post the link to that blog post in the chat again just a few minutes ago. Okay, so the next question is, do you constrain either the number of requests per time per requester or the size of a single request? Jim?
So that so many great questions. Right now, no. And I ask you to be kind as a person, because it is certainly possible to take this system down right now because it's on labs. We are exploring ways to make that happen, because on water services, this is actually a pretty common situation, is that which is unthrottled. Anyone can ask as much data as possible. Most people are good. Occasionally we'll have people that can take the system right down. And so we'll be probably implementing some sort of a layer that where as a user without a key, without an API key, you might get one level of service, which would be relatively low. You can explore it, but if you want better service, then you can register with us. And then, but we will be doing things like starting to throttle and other things just to allow for better system stability as we move forward. But exactly how that works hasn't been figured out yet.
Okay. This user asks, if I am using data retrieval in R to obtain time series data, is that library already using SensorThings, or will it in the future? Jim?
So it currently is not using SensorThings, but in the future, yes, it will be using SensorThings to get data among other data sources.
Okay, I love this question. This person asks, if I'm new to APIs in general, can you suggest a place to start learning or tutorials for practice? I'm going to add, before you answer the question, Jim, I'm going to add, definitely email us if you think that there is more specific offerings that we can provide to help you. Jim?
That is a great question, and I'd love to talk to you more about from your background. There is a lot of different places to start. One place that I would actually recommend starting is with the R-based data retrieval library, because it gives you, we have so much information in that space to be able to allow you to start interacting with water data. And it abstracts a little bit of the API data structure away and gives you a lot more information. There's certainly other things that you can do as well. Right offhand, I do not have some great intro content, but that's a great question. And one of my goals here is that we want to build systems that are for users who've never used an API before. As we move forward, we really want to make these things as accessible as possible.
Thanks, Jim. Okay, we're going to take a few more questions, and then as you can see, we are just a few minutes from the end of this webinar. So one of our last questions is, what about software libraries for other languages, such as .NET? Jim?
So right now, our focus will be on for our software, for actually building client libraries. The focus will probably continue to be on Python and R. Other tools like .NET, we may be able to get somewhat for free, say by moving the standard to fit exactly what's going on. And also we want to hear from our users. And if it turns out that we actually have a very large .NET user base, that's going to be a great thing for us to know that we can then potentially put resources toward client libraries in the future.
Okay. This user asks, are there any quality flags published with the time series data, either automatically or by USGS staff? Jim? Yeah.
So as of today with SensorThings, no. As of probably Wednesday, yes. So both things like masks, if a data stream is affected by ice, and also things like whether it's approved and other types of quality structures. And this is where we'll actually be able to do way more with SensorThings and with our future systems than with our legacy systems, where we're limited to a single qualifier. And so both approval status and also different types of time point specific metadata will become much richer as we move forward.
Great. All right, this is our second to last question. Does USGS publish detailed sensor specifications or sensor calibration data? Jim?
Currently, no. If you may be able to get the information if you know the right person at the Water Science Center. And this is a great example of something, again, where right now in SensorThings, we are putting out a single sensor. the USGS sensor. But we'll be able to put more of this information out, and we want to be able to think about and work with our users to figure out what pieces of sensor metadata are the most important for you to make use of this data as it's coming out. And so this again is an area that we're just going to be figuring this out and working with all of you to understand what would be most helpful for you moving forward.
Great, thanks, Jim. The last question of the day I'm going to ask to Emily Reed. That question is, what is the timeline for moving away from legacy websites and web services? Emily?
Yeah, thanks for that question. We're looking at a timeline of about 3 years out from now for modernizing waterdata.usgs and waterservices.usgs. And we're going to be doing that in kind of a sequential fashion. And what I can assure you is that there will be communication both on the resources themselves. Like, for example, we've got a notice up right now on the current conditions pages, the monitoring location pages, that we're working on a modernized replacement of it. And we'll continue with that kind of communication on the resources themselves, as well as through webinars like this to let people know about what the timelines are so that they can plan, adjust their workflows, as well as take advantage of the new water data resources like the one that you heard about today. One other thing I want to mention while I have the chance is just that we are currently conducting an annual survey of NWIS users. So if you're a current user of waterdata.usgs.gov, we would love for you to take 5 minutes or so and let us know what your satisfaction of that site is, and we use that to help improve the site over time. So that's it from me, Nicole.
Thanks, Emily. Thank you, everyone, for joining this webinar. This webinar has been recorded and will be available within the next week on our USGS YouTube channel and also on the Water Mission Area website. Thanks again for everyone for attending. Definitely be sure to register for future webinars in this series. We will be talking about OGC in the next webinar in February, and then in April, we'll talk about what's next for USGS new APIs. Thank you, everyone.